The universe is hiding something. Welcome to Universe Secrets, where we journey deep into the cosmos to uncover the most profound mysteries hidden within the dark. Pluto sits silently at the frozen edge of our solar system, a world that has baffled astronomers for decades with its secrets. For a long time, we thought we understood this dwarf planet, but recent discoveries have completely shattered our previous scientific models. The atmosphere of this distant world is behaving in ways that physics suggested was impossible, creating a mystery that demanded an answer. Why is the atmosphere of Pluto so much colder than anyone predicted? And what forces are at work in the dark? To understand this puzzle, we must go back to the historic mission that gave us our first clear look at Pluto. In the summer of 2015, humanity finally reached out and touched the edge of the solar system's frontier. The images returned were breathtaking, revealing a complex world of flowing nitrogen glaciers and towering mountains made of rock-hard water ice. It was a moment of triumph for space exploration, providing us with a treasure trove of data that would take years to analyze. However, hidden within that celebration was a confusing set of numbers that did not match any of the pre-flight predictions. Models suggested the atmosphere should be around 100 Kelvin, but the data showed it was significantly colder than that estimate. The actual readings hovered between 65 and 70 Kelvin, a difference of 30 degrees that science could not initially explain. Scientists knew the atmosphere was composed mainly of nitrogen, with traces of methane and carbon monoxide, which usually trap heat. According to standard physics, these gases should absorb sunlight and warm the atmosphere, acting like a blanket around the frozen planet. But instead of warming up, the atmosphere was effectively cooling itself down, defying the standard laws of planetary climate modeling. This discrepancy created a significant gap in our understanding, leaving researchers scratching their heads for several years after the flyby. For 2 years, the scientific community struggled to find a plausible mechanism that could explain this extreme atmospheric cooling effect. Then, in 2017, a researcher named Xi Zhang proposed a bold new hypothesis that changed everything. He suggested that the answer lay not in the gases themselves, but in something suspended within them: solid haze particles. High in the atmosphere, ultraviolet sunlight triggers chemical reactions that fuse simple gases into larger, complex organic hydrocarbon chains. These particles, known as tholins, clump together to create layers of haze that shroud the dwarf planet in mystery. New Horizons had actually captured images of this haze, appearing as stunning blue layers extending high above the surface. While scientists knew the haze existed, they had underestimated its thermodynamic role, assuming it just scattered light like smog. Zhang proposed that these particles absorb solar energy and re-emit it as infrared radiation, effectively dumping heat into space. Instead of trapping heat like a greenhouse gas, the haze acts like a radiator, actively cooling the atmosphere down. This cooling effect was calculated to be strong enough to overpower the heating from gases, explaining the 30-degree discrepancy. It was a compelling theory, but in science, the hypothesis is nothing without concrete proof to back it up. Proving this was difficult because ground-based telescopes could not separate the faint heat signal of Pluto from its background. We needed an instrument capable of seeing the universe in mid-infrared light with unprecedented clarity and sensitivity. Enter the James Webb Space Telescope, the most powerful observatory ever built, launched to unlock the secrets of the cosmos. Equipped with state-of-the-art instruments, Webb was perfectly designed to test Xi Zhang's haze cooling hypothesis once and for all. Specifically, the mid-infrared instrument, or MIRI, was the key tool needed to detect the thermal fingerprint of Pluto's haze. In 2023, astronomers pointed this $10 billion eye toward the edge of our solar system. The challenge was immense because Pluto and its moon, Charon, appear incredibly close together from our perspective on Earth. Webb's superior optics allowed scientists to separate the light of Pluto from Charon, analyzing the thermal emissions of each. The data streamed back to Earth, carrying the spectral signature of the atmosphere in wavelengths we had never seen before.
Look, the
Researchers
JWST data
anxiously
points align
analyzed the
perfectly with the
mid-infrared
2017
brightness,
model.
looking for evidence that the haze was indeed radiating heat into space. The results were conclusive. The thermal emissions matched the predictions of the haze cooling model almost perfectly. Webb confirmed that the organic haze particles are the dominant drivers of Pluto's climate, actively controlling its atmospheric temperature. This discovery solved the decade-long mystery, proving that solid particles can be more important than gases in planetary climates. Unlike Earth, where gases trap heat, Pluto demonstrates a unique climate system driven by the cooling power of solid haze. This finding has profound implications that extend far beyond Pluto, reaching out to other worlds in our solar system. Titan, Saturn's largest moon, shares similar atmospheric chemistry, and this discovery helps us refine our models of its climate. It also provides clues for Triton, Neptune's captured moon, which may operate under similar unique atmospheric rules. Even more exciting is what this means for the study of exoplanets orbiting distant stars throughout our galaxy. Many exoplanets likely possess hazy atmospheres, and we now know that we cannot ignore the cooling effects of these particles. This research even lets us look back in time at our own home, simulating Earth's atmosphere billions of years ago. Before oxygen became dominant, Earth may have been cooled by similar organic hazes, influencing the conditions for early life. Pluto has transformed from a distant, frozen oddity into a Rosetta Stone for understanding atmospheric physics across the universe. The collaboration between past missions and modern telescopes has bridged the gap between theory and observation in spectacular fashion.
Look at this energy
This breakthrough proves that even the coldest, darkest corners of the solar system
We just found
have
evidence
dynamic
of
stories to
subsurface
tell
ocean
us.
activity.
As we continue to explore, we realize that our models must always evolve to match the complex reality of nature. The universe is full of surprises, and sometimes the answers are hidden in the microscopic dust floating in the dark. From a tiny haze particle to the climate of an entire planet, everything is connected by the laws of physics. Perhaps one day, we will send a lander to Pluto to sample these haze particles directly and learn even more. Until then, we rely on our remote eyes like James Webb to continue peeling back the layers of cosmic history. Pluto is just the beginning. The Kuiper Belt is filled with other icy worlds that may hold similar atmospheric secrets. James Webb continues its mission, scanning the darkness for faint thermal signals that reveal the composition of distant worlds. We have corrected our textbooks, updating the temperature graphs of Pluto to reflect the cooling power of organic haze. In less than a decade, we went from complete confusion to a sophisticated understanding of this dwarf planet's complex weather. The beauty of Pluto is not just in its icy mountains, but in the invisible physics that govern its sky. These cooling particles eventually settle on the surface, painting huge regions of the planet in deep, dark red hues. This process creates features like the Cthulhu Macula, a vast dark region formed by billions of years of fallout. It is a dynamic cycle of creation and deposition, linking the atmosphere above to the geology on the ground below. New Horizons gave us the question, and James Webb gave us the answer, a perfect example of scientific continuity. Every discovery like this adds a new page to our knowledge, refining our understanding of how planetary systems evolve. We are now looking at the gas giants with fresh eyes, wondering if similar cooling mechanisms are hiding in plain sight. The debate is no longer about if the haze cools the planet, but exactly how efficient this process truly is. Human curiosity drives us to ask these questions, pushing the boundaries of technology to see what was once invisible. In the vast silence of space, Pluto continues its long, slow orbit, guarding the secrets of the outer solar system. Its frigid temperatures are no longer just a statistic, but a key piece of evidence in a grand cosmic puzzle.
I never thought
As
I'd
we
see it
look
with
to
my
the
own
future,
eyes.
we can imagine a time when
beautiful.
humanity might visit these twilight worlds in person. The organic chemistry happening in Pluto's sky might even hold clues to the origins of prebiotic material in space. Could these same cooling haze particles have played a role in protecting the delicate molecules needed for life elsewhere? While that remains a question for another day, the mystery of Pluto's temperature is one case we can finally close. From the initial flyby to the theoretical breakthrough, and finally the telescopic confirmation, it has been an incredible scientific journey. It reminds us that our understanding of the universe is constantly evolving, challenging us to keep looking up and wondering. Pluto may be small and distant, but it has taught us a massive lesson about the complexity of planetary atmospheres. The stars shine just as brightly there as they do here, witnessing the silent cooling cycle of this frozen world. As Pluto continues its long journey around the sun, its atmosphere will continue to breathe, expand, and freeze. New Horizons is now far past Pluto, exploring the deeper Kuiper Belt, but its legacy at Pluto remains unmatched. And James Webb stands ready to solve the next impossible puzzle that the universe decides to throw our way. What other secrets are hiding in the darkness? What other theories will be overturned by the next generation of data? The pursuit of knowledge is a never-ending quest, driven by our innate desire to understand the world around us. Pluto captured our hearts with its appearance, and now it has captured our minds with its fascinating atmospheric physics. Data from this discovery is currently being used to update climate models for planets that we have not even discovered yet. It serves as a reminder that the solar system is a complex, interconnected family of diverse and unique worlds. Even with so little sunlight, the energy dynamics of this planet are vibrant, active, and surprisingly complex to model. Nature has a way of balancing itself, finding equilibrium even in the most extreme environments known to science. It may be smaller than our own moon, but Pluto's contribution to planetary science is absolutely massive in scale. We owe a debt of gratitude to the engineers and scientists who make these incredible voyages of discovery possible.
Execute the jump to warp.
As we push further into the void, we carry the lessons learned from Pluto to guide us to new frontiers. Somewhere out there, orbiting another star, there's likely another world cooled by haze, waiting for us to find it. Thank you for joining us on this deep dive into one of the solar system's most chilling and fascinating mysteries. We hope this video has shed some light on the cold darkness of Pluto and the science that illuminates it. If you enjoyed this journey, please hit the like button and share this video with fellow space enthusiasts. Don't forget to subscribe and ring the bell so you never miss an update on the secrets of the universe. Check out our other videos to continue your exploration of the cosmos, from the red sands of Mars to distant galaxies. We love hearing from you, so leave a comment below with your thoughts on Pluto or what we should cover next. The universe is vast and full of secrets, and we are just scratching the surface of what is possible to know. Keep looking up, keep questioning, and never lose your sense of wonder for the magnificent cosmos that surrounds us all. This has been a production of Universe Secrets, dedicated to bringing the wonders of space science directly to your screen. We appreciate your time and attention, and we look forward to seeing you in the next episode of our series. Until next time, stay curious, stay inspired, and keep exploring the infinite secrets of this beautiful universe we call home. Goodbye for now, and thank you for watching Universe Secrets, your gateway to the stars and beyond.